Okay, hello and welcome. We really appreciate you being here. We know it's a lot to take yourself away from either the counter or the field to spend a little time with us. But hopefully, this is something that's going to help you when it comes to electronic throttle body sales and give you some great information for some good conversations going forward. So, with that, again, obviously, today's conversation is on ETBs. And what are we going to discuss? Well, we're going to briefly touch on what they do. It's kind of a high level look. We're going to do a conversation on why they fail. And there's a couple of different reasons. There's some that are very typical and some that are unfortunately just, design flaws. And we're going to talk about those. We'll talk about a couple of quick tech tips that might help even yourself if you're working on your own throttle body or those technicians out there that might be struggling with one. And then we're going to go over a couple of engineering improvements that are going to make it a lot easier for you to have conversations on electronic throttle bodies because they are the leader in the market when it comes to quality. And I want to pass it over to our product team and Patty, and we're going to talk a little bit about the competitive landscape and what that looks like for you and what that competition out there looks like. And then we're going to pass it off to our marketing team and just give you an update on some of the sales support that we have for you, not only in the field, but also as far as digital and print. So let's talk about what electronic throttle bodies do. It's actually pretty simple. They have taken and replaced the cable. The cable is no longer there. We no longer have a gas pedal with a cable attached to a throttle body. So we don't have those adjustments with wire anymore, like an actual cable. We have drive-by-wire in the sense of pigtails, in the sense of sensors. And so what happens is that driver is going to press the accelerator pedal, which is going to send the electronic signal to the vehicle's ECU. Now, if you look on the screen, you can see there's a lot going on all at one time. So you would think, well, why would we get rid of a cable if we have to add all this in? Well, because it gives us more economy. It gives us more fuel economy. It gives us better acceleration. It gives us, in some cases, even more power because we don't have a delay. But we do have a lot of things that have to work in unison to make sure that the throttle body is actuated properly and we get the proper fuel and air and spark that we need. So again, you see on the screen here, we start with the APP, the accelerator pedal position sensor. And once we push our foot down on that, we're sending a signal to the ECU. And the ECU now has to say, okay, let's get that throttle blade opened up based on the command of the pedal. So however hard you push down on that pedal, we're going to try to command the throttle body to keep up with that command. But there's a lot that has to take place. So again, we see here on the screen, throttle body, we have fuel delivery that's in play, we have spark timing that's in play, we have cam timing that's in play, even mass airflow temperature, NOx sensor, and so many other sensors. And if you look on the bottom right-hand side here, we got an ABS control module. What would ABS have anything to do with a throttle body? Well, it all works together so that not only the ECU knows what's going on, but the PCM knows what's going on. And we have a smooth transition from the time we hit the pedal to the time we let off the pedal. It's all seamless. So no more cable. It's all drive-by-wire, meaning we have pigtails and sensors doing basically all the work for us through those computers. So again, what do? It's very simple. They're going to use all that data from the position sensor, the mass airflow, the NOx sensor, and the ECU, and they're going to send those commands and adjust the throttle blade based on what the command is from the driver and then what the demand is from the fuel delivery, spark timing, and cam timing. So remember, as we're commanding the pedal, we're kind of demanding things from the motor to do what we want it to do. And so it all has to work there. And the way we get that done after the fact is a two-way electric motor that controls the throttle blade. So all of that is taking place all at one time just to get a little bit of power to this little bitty motor right here that's going to actuate that throttle blade. And we all know that little round plate inside of the throttle body that flips back and forth. This is the motor that actuates that. So very simple, but not really. Whole lot going on there, right? Well, let's talk about why they fail, because you would think of all of those things going on, there's probably 1,000 different reasons why they would fail. And really, there's not. There's actually just a few things right here. So remember, they're not entirely electronic. So we're talking about drive-by-wire, sensors, pigtails. We're taking out the cable, but we still have some mechanical gearing in these throttle bodies that is required to open and close the throttle blade and, make it function the way that it's supposed to. And they're sealed units. So everything you see there inside of that throttle body is sealed up, but it's not lubricated. There's absolutely no lubrication in there, no oil, very little anything to keep those parts lubricated. And they're moving millions and millions of times throughout their life cycle, through harsh conditions, heat, cold. There's a whole gamut of things that come together that cause these to fail internally. And a lot of times it's the teeth of the gears that are going to cause the biggest failure. And as you see here, we have an original equipment electronic throttle body with an all plastic gear train. That's going to come up here in a second. You're going to see why we pointed that out. And again, the geometry of the gear train and the materials used on the gears are critical to performance and reliability. Remember, these are not lubricated, they're sealed. There's no way to service these. Once you unseal them, it's not like you can just throw something in there and it's going to make it all better. If these are starting to wear out, they've already worn out. It's time they need a replacement. And so one of the biggest things is, again, that geometry and the quality of the gear. But there's other reasons electronic throttle bodies fail that are actually a little bit more common. So the gears can fail, absolutely, and they do, unfortunately, very often. But one of the biggest things we deal with is carbon buildup on the throttle blade. Now, this is just a common thing. We're going to have carbon buildup, but unfortunately, a lot of these fail after somebody tries to correct the carbon buildup or they let it go too long. And we'll talk about that here in a second. But you could also have a failed throttle position sensor. But remember, we don't have throttle position sensors if we have an ETB this way. It's all incorporated, so we can't really replace that. And there are some cases that's true, but most cases you cannot replace that throttle position sensor. It is part of that gearing or that electronic componentry of the ETB. We could also have the electric motor go out. Again, we're doing millions of cycles back and forth, opening and closing the throttle blade. Stands to reason that motor can go out, but again, it's internal. We won't be able to replace just that motor. We have to replace the ETB. And then again, one of the more commons is gear train failure. So these are a lot of the main reasons. And really, that's only 5, right? So we've got mostly gear train failures, carbon buildup, failed throttle position sensor, electronic motor failure. And then we can also have electronic circuit issues. So we might have a pigtail that's bad. We may even have the connectors to the ETB that have gone bad. And again, unfortunately, in those cases, we have to replace the ETB. And again, other component systems that could have an effect on an ETB would be wiring faults, some poor connections. And then we can even have some intermittent issues where we don't have the right communication with the ECU or the PCM because of a wheel speed sensor, a brake switch, or even a mass airflow sensor. So there's a lot of things that can lead us to thinking an ETB has failed, but there's really only a couple handfuls of things that do cause them to fail. And we're going to address those in our program here, right? So here's a couple quick tips before we get into what we've done to correct some of these. So remember, the ECM is going to compensate for carbon buildup. I talked about carbon a second ago, and it's one of the biggest reasons that we have failures when it comes to ETBs. And so what happens is, let's say the vehicle has 100,000 miles on it. Well, there is absolutely no way there's not carbon buildup on that throttle body after 100,000 miles. And so what's happened is, throughout that 100,000 miles, the ECM has compensated. It's noticed that the throttle blade is not coming back as far as it used to or going forward the way it used to. So what it does is it compensates. And so that way we don't have a rich situation or a lean situation. It adjusts so that it can make sure when that demand is there, we're putting the right fuel, spark, and everything else together without adding too much air because we've had carbon buildup. So if we have carbon buildup and if we've cleaned it, we have to make sure we do a relearn procedure. Anytime we take one of these throttle bodies off and have anything done to it adjustment wise, sometimes even just taking it off and doing nothing will require doing a relearn procedure. So make sure, again, if you're working on your own or if you're talking to a technician that's having an issue, maybe they cleaned one, they're like, hey, this thing is idling at 1400 RPMs. It probably needs a relearn. So make sure we do that every time. And it is going to, vary depending on the vehicle. On most, you can do a manual relearn. And sometimes it's a situation where you cycle the key, press the gas pedal, and then, roll the window down or something like that. But there are some situations, Nissan, for example, where you may need a scan tool. But either way, that relearn is going to be required, not a reprogram. And I don't want to make a distinction there. We're not programming the ETB. There's no reason to program the ETB. It's relearning it. And all we're doing in a relearn is letting the PCM know, hey, this is a new throttle body, which means the blade is completely closed the way it's supposed to. So now we're going to tell the PCM, readjust back to the way it was when it was new. And that way we get the right fuel, air, all that good stuff. So remember that when we're doing anything with an ETB, we got to make sure we do a relearn. Now, if we have some intermittent faults, again, another tip here, monitor that circuit. So if we have an intermittent fault, maybe we can't reproduce it every time. Let's throw a scan tool on there and let's watch the graph and let's see if it cuts in and out or something like that. Usually, if that's the case, it is going to be pigtail related or connector related. The pigtail may be fine, even the connector may be fine. It just may be loose. So using something like a Stabilant 22A will absolutely, actually bond that connection much better, and you won't have those intermittent faults anymore. So now we know we need to clean them. We need to make sure that they are relearned. We need to make sure that we have a good connection. Now let's talk about what the options are. So we have to remember, and I used to say this years ago all the time, when a customer comes through the door of a parts store, they don't want to be there, right? They didn't wake up this morning and say, oh, I really hope my fuel pump goes out. That's just not the way it works. So when they come in, it means something has failed. And that's exactly the truth with ETBs. They don't replace it unless it fails. There's no reason to. So when it does fail, we have three options. We have three ways we can recommend it to them. We can offer them a value line part. And in most cases with electronic throttle bodies in the value line, they are remanufactured. They use older electronics, and they're not going to include the required gaskets. They're also not going to have any updates because they are remanufactured. Or we could try to offer them an OE service part, maybe direct from the dealer or, an OE service name. But we have to remember the same design as the part that just failed is what's in that box. And in some cases, they fail prematurely. And once again, it may not include the correct gasket because a lot of times those are sold separately when it comes to OE. Or you could offer the standard, which is what we think you should do, because what you're going to get in our box is a 100% brand new, not remanufactured. It's going to have design improvements that we're going to talk about here in a second for durability, especially on applications with high OE failure rates. And the popular applications are going to include those gaskets because there are some popular applications that you can't do this job without replacing the gasket. So again, these are your options. Now let's talk about what we can do to show the customer why standard is the way to go. We already know they're 100% new. There's no remanufacturing. They'll have that seal. Well, let's look at some of the common issues that we've corrected in our box with our ETBs so your customers can have confidence. So here's one example. Chrysler Pentastar 2.0 and 2.4 liters. Seems like we talk about these cars quite a bit, right? They are known for their high failure rates. And the problem is the gear teeth prematurely wear, one, because they have a very poor geometry. It just was not designed properly. And that gear is a super soft material. You can see there in the little bubble on the left side, it just kind of looks like a little bit of dirt built up. That used to be a gear. That used to be a plastic gear inside of that ETB. Well, that's not going to do a very good job of opening or closing that throttle blade, is it? So what we did at Standard is we redesigned the internal components, right? We increased the face width on the gear to reduce stress on it. Then we improved that geometry of the teeth for added strength. So they're a little bit thicker and a little bit shorter. So the geometry is better. They're not going to grind the way they used to. We have a better width on the face of the gear. And then we upgraded the material of the gear to a stronger, higher temp synthetic material. So in this example, we're going to use a synthetic material, and we're going to change the geometry and everything else to make sure that these do not wear out the way you see in that little bubble picture there. And we're not grinding plastic teeth off. That's one of the biggest problems. So we've corrected that with ours. So when you do sell an ETB for a 2 liter or 2.4, we've basically fixed all of the high failure rate problems with that ETB. And it's probably going to be the exact, the last one that the customer has to put on the vehicle. Now, here's another example of where we have done design improvements. And I know this is one of the first ones that we really went after. And this is well over 10 years ago, because these were such a high failure rate on the 5.3 liters. Now, when we look at the OE and the competitor, you can see why it failed. It's a plastic gear. So just for reference, when we test these, before they go on our box, before they end up on your shelf, and before we have calls like this to tell you they're the best thing ever, we verify that, right? So we have to go through all these testing phases. And in both of these examples, these were put on an endurance test stand. And with the plastic gear, it didn't last more than 10 days. The plastic gear failed, and we no longer have a working ETB. Well, if you look to the right, what's the difference? Well, we updated this again, well over 10 years ago, to a steel gear. So instead of that plastic gear failing now, we don't have to worry about it. We have a steel gear inside the ETB, very high strength, and it was still intact after 45 days of endurance testing. I think we can agree that after 45, we can just go ahead and shut it down. We see that it's going to work a lot better. So again, what have we done in some of the improvements? Well, we fixed things on the Chrysler Pentastars. We've made sure that those teeth aren't grinding and tearing apart. And then we see on the 5.3 liters, we're doing the same thing. The only difference here is because of that type of system and build, it needed a stainless steel gear. So that's what it has now. And you no longer have to worry about those gears falling apart on the 5.3 liters. So as a whole, when we look at the standard electronic throttle bodies, we're putting out a premium product. We're correcting OE flaws. We're giving 100% new components, unlike the value lines. And we're making sure that you get everything you need with it, again, including a seal for a complete repair. So again, accuracy, design improvements, durability, and all made in North America, wildly tested. So I'm here in Irving, Texas. We're doing the call from here right now, but about 30 feet away from me is a vehicle test facility where we actually have technicians that validate our parts on real cars for thousands of miles at a time. These ETBs are no different than any other part in our lineup. We do that testing with those as well. So again, the best parts make the best parts. We've got the stainless steel gears. We've got enclosed contact brushes. We've got sealed constructions. We've got, because this is a big one, corrosion resistant housings, and then stainless steel throttle plate shafts. So we don't have to worry about the shaft itself wearing out, even if we have a good throttle plate, and an electric motor that we have tested from negative 40 degrees to over 240 degrees for performance in extreme conditions. So I like to say it, and our marketing team came up with a great way of saying it about a year ago. That's what's in our box. And our question to the competition is, what's in yours? And with that, I'm going to pass this over to Patty and our product team to talk about that. What does that competitive landscape look like? So Patty, the show is yours. I think they're ready for you. They may not want to hear me talking anymore.
Thank you, Corey. Hi, everyone. My name is Patty Grogan, and I'm one of the product managers here at Standard. So let's take a quick look at the competitive landscape as shown on this slide. I know you probably hear a lot of claims about the coverage, but this is the real picture. Standard leads the pack with 218 SKUs and coverage of over 210 million vehicles in operation. That's more than anyone else on this board. And what does that mean for you? It means fewer special orders, fewer missed sales, and more chances to say yes to your customers immediately. We're built for this, giving you the coverage and confidence to deliver quality without hesitation. Because at the end of the day, it's not about having more SKUs, it's about having the right SKUs, backed by quality you can trust, to strengthen and grow the relationships you have with your customers, making you their number one and preferred call every time. Next slide. Building and maintaining strong relationships and keeping you as your customer's go-to call when something goes wrong is very important to us. We want to make sure you've got everything you need when it comes to electronic throttle bodies, and that means more than just the ETB itself. And as shown in the slide above, we back it up with throttle position sensors, pedal position sensors, variable intake manifold actuators, clean plug-and-play connectors. No scrambling, no callbacks, no outsourcing parts and waiting for them, just a full solution ready to go. And because it's built and backed by the same engineering team that understands this technology inside and out, you can recommend it with confidence. Now, when it comes to throttle position centers, we're not cutting corners. In fact, many of these are built right alongside our electronic throttle bodies in the same high quality facilities. Inside, we've got an integrated circuit that does the heavy lifting. It precisely measures throttle shaft movement and gives you that accurate linear signal you can rely on. But what really sets us apart is the magnet. It's molded into a high performance polymer and it locks it in the right spot and minimizes friction on the bearing surfaces. Then it is sealed up with a custom elastomer seal that keeps moisture out. We've seen firsthand that's a common failure point in some competitor sensors. The result? A sensor that's reliable, consistent, and built to outlast the environment it lives in. Let's talk about accelerator pedal position sensors, or APS for short. They are mission critical for modern throttle control, and we make sure every single one of ours is 100% tested to deliver the most accurate signal versus pedal position. Standard has over 340 SKUs in the lineup, covering 3 decades worth of Standard vehicles, which mean when that repair opportunity comes in, Standard more than likely has the solution. What about performance? Our designs are engineered to contact with just a few grams of force, so acceleration and deceleration feel smooth and responsive. Plus, we build in high-strength dual return springs that gives the pedal that confident, consistent feel drivers expect every time they hit the gas. At Standard, we are proud to be one of the few true basic manufacturers of electronic throttle bodies in the North American aftermarket. Every ETB we make is calibrated and tested in-house, including output, voltage, validation, but we don't stop there. We go beyond the bench and into real world with on-vehicle testing at our facility in Texas, as Corey mentioned earlier. This gives us a huge advantage. Many offshore suppliers simply don't have access to the wide variety of test vehicles we do, and it shows in the results. With Standard, your customer gets a part that's been through rigorous lab testing and real world driving. So when your customer pulls it out of the box, they can install with confidence, knowing it's built to outperform the competition. And with that, I would like to thank you all for your time, and I'll be handing things over to Marketing Services, who will walk you through the tools available to support these high-quality products. Stephanie, it's all yours.
Good morning. My name is Stephanie Bardakoff. I'm the Marketing Communications Manager here at SMP. And today I'm just going to talk to you a little bit about the materials that we've been creating to support our ETB program. We've gone over a lot of great information here on this call today, and these pieces really just help reinforce a lot of this messaging to help explain our ETB program and why choose Standard. So our support doesn't end by putting a part in a box. Here at the top, you'll see our ETB program brochure. This brochure does a great job of explaining what goes into our ETBs, like research and development, precision manufacturing, testing and analysis, as well as showing design improvements and features and benefits. We also have the What's in Your Box ETB flyer, which is a great quick overview of our program, including the testing we subject our ETBs to. Finally, you see there on the bottom right, our latest new parts spotlight flyer. This features new applications as well as up-and-coming numbers that we recommend be added to customers' shelves as we're really starting to see serious movement on these applications. Next slide. So now that we've gone over our printed support materials, we also offer digital sales support. So we created an ETB What's in Your Box training video that's available on our YouTube channel that really goes over how ETBs fail and what to look for in a replacement part. It's a great, quick 4-minute resource. That video is part of a larger YouTube channel, the Standard brand channel, that has a full designated ETB playlist as part of a library of over 700 videos. So there's a lot of great content to watch there. We also took time to create a digital product guide, which provides additional technical information about our throttle bodies and really deep dives into the features and benefits, new and top selling numbers, tech tips, and more. This guide can be found at standardbrand.com. You just go to the top right, you'll see digital resources, type in digital portfolio, and all of our digital product guides will come up and be able to be downloaded from that page. We've also placed print ads in popular aftermarket trade magazines to further explain what's in the standard box. In the case of our ETBs, that's design improvements for durability and optimized performance. Next slide. In closing, all of these materials are really just created around driving home what's in the standard box. When you choose a standard ETB, you're choosing industry-leading coverage and ETBs that have been designed and built in North America with design improvements on applications with high failure rates. Many of our popular ETBs include the required gasket for a complete repair, and our ETBs can be installed with confidence because they've been tested and validated in the lab and on actual vehicles. Thank you all for your time this morning, and I'll pass it back to Corey.
And thank you, Stephanie. And thank you, Patty. Again, I think it's all great information. And, I look at calls like this when we're at the end of it and we don't have any questions. That means our message was clear and concise, which means hopefully now our folks that are listening can go out and pass along that clear and concise message. So everyone, again, thank you for being here. We'll see you next month for gas fuel injection. And my hope is that within the next 30 minutes, someone's going to need an electronic throttle body, and you're going to know exactly which one to promote to them. So thank you again. Have a wonderful day, and we'll see you next month.